Hey everybody, so we're going to talk about graphs of rational functions. Before we actually start graphing, we're going to talk about the tools that we need to graph. So the first one is asymptotes. Okay, and we're going to talk about three different types of asymptotes. The first one is a vertical asymptote. Okay, so a vertical asymptote is a line that the graph never crosses or touches. The graph should go along that line. Okay, and you get a vertical asymptote when the denominator of the function is 0. Okay, so you get a vertical asymptote, like I said, when you have a value that makes the denominator 0. Okay, so for example, we'll do lots more examples, but for one example, okay, this function would have a vertical asymptote at x equals 2 because that's what makes the denominator equal to 0. Okay, the next type of asymptote is a horizontal asymptote. Okay, so this is a horizontal line. Okay, and the ends of the graph should go along that horizontal line. Okay, this is taking the place of what we talked about with polynomial graphs when we said end behavior. Okay, so this really tells you what the ends of the graph look like. Okay, you get a horizontal asymptote when the degree of the numerator and denominator is equal. Okay. So how you actually find it okay, is by looking at a fraction of the leading coefficients. Okay, so let's do one example. Like I said, we'll do a ton more, but for one example, if you have x squared plus 3x minus 5 over 2x squared minus 3x minus 1, okay, you can see that they have the same degree. They're degree 2, okay, and then you would make a fraction of the leading coefficients, right? So the leading coefficient here is 1. The leading coefficient in the denominator is 2. Okay, so this would be our horizontal asymptote. All right, the last type of asymptote is a slant asymptote. Okay, and these are also called oblique asymptotes. Okay, so this is a normal line, like a slanted line. Okay, and again, this tells you how the ends of the graph look like. So it's a lot like a horizontal asymptote, it's just that the line isn't completely horizontal. Okay, so this happens when the degree of the numerator is 1 more than the degree of the denominator. Okay, and you actually find it by doing division. Okay, so we'll just do an example of not actually finding it, but an example of something that does have a slant asymptote. Okay, so this is an example of a function that has a slant asymptote. You can see that the degree of the numerator is 2, the degree of the denominator is 1, so there is a slant asymptote. Okay, all right, so let's do some examples of finding asymptotes. Oh, there's one more horizontal asymptote that I forgot to talk about. Okay, so you can get a horizontal asymptote that's at y equals 0, which is the x-axis. Okay, and this happens when the degree of the denominator is greater than the degree of the numerator. Okay, so normally I would make a little table to summarize. Okay, so all right, so if you have the degree of the numerator is less than the degree of the denominator, that's the example that we had up here, okay, then this would mean you have a horizontal asymptote at y equals 0, okay? Now, if they're equal, okay, then you have a horizontal asymptote, okay, and it's at the ratio of the leading coefficients. Okay. If the degree of the numerator is 1 more okay, that means you have a slant asymptote. Okay, and if you have that the degree of the numerator is more than the degree of the denominator more than 1, right? So for example, if this is 1 and this is 6 or something like that, then there are no horizontal asymptotes and no slant asymptotes. Okay, so let's look at an example. Okay, so the first thing to find is the vertical asymptotes because those are the easiest, okay? And remember, those are the roots of the denominator. Okay, so that's going to be x equals 5 because that would be what makes the denominator 0, right? Or what makes the expression undefined, okay? Then we're going to look for horizontal or slant asymptotes, okay? So the degree of the numerator is 0. The degree of the denominator is 1, okay? So this is bigger, okay? Which means we have a horizontal asymptote at y equals 0. Okay. All right. Let's look at another example. Okay, so again, we're going to start with the vertical asymptotes, and that's going to come from the roots of the denominator. So here it's going to be x equals -2. Okay, and then we're going to look at the degree. So the degree of the numerator is 1, and the degree of the denominator is also 1, right? X to the 1 power, x to the 1 power. So these are equal, okay? So that means we're going to make a ratio of the leading coefficients. So our leading coefficient from the numerator is 2, leading coefficient from the denominator is 1. So our horizontal asymptote is going to be y equals 2. Okay? All right. Let's look at one more, maybe two more. Okay. All right. So the vertical asymptote is going to be the roots of this denominator. So there's still only one root. Still only x equals 1. And then we're going to look at the degrees. So the degree of the numerator is 1. Okay. The degree of the denominator is 2. So this is much larger. Okay. So that means there is a horizontal asymptote at y equals 0. Okay. All right. So let's do another example where we look at some slant asymptotes. Okay, so the first thing we would say is that we have two vertical asymptotes, right? 1, 0 from each of these. So we would have x equals -2 and x equals +3. Okay, this doesn't actually have a slant asymptote because the degree of the numerator is 1, the degree of the denominator is 2, which is bigger. So we have a horizontal asymptote at y equals 0. Okay, let's look at one that actually does have a slant asymptote. Okay, so here we're still going to have a vertical asymptote that comes from the denominator. So we'd have x equals -1. Okay, the degree of the numerator is 2. The degree of the denominator is 1. Okay, so this is equal to the degree of the denominator plus 1. Okay, which means we have a slant asymptote. All right, so now we're actually going to find this slant asymptote. Okay, and we do that using division. So we're going to divide x plus 1 into the numerator. Okay, so x into x squared is x, multiply and subtract. Okay, so this is going to be -1, and then I would have minus x minus 1. This is -3, which actually is not super important. Okay, now the slant asymptote comes from the quotient here. So we would have y equals x minus 1 as our slant asymptote. Okay, let's do another one like that. Okay, so our vertical asymptote is going to come from the root of the denominator, so that's going to be x equals 2. Okay, the degree of our numerator is 2. The degree of the denominator is 1. Okay, so this is equal to that plus 1, which means we have a slant asymptote. Okay, so we're going to divide to find it. So we'll divide x minus 2 into 2x squared minus 4x minus 3. Okay, so x into 2x squared is 2x. Okay, we get 0. Okay, so -3 is our remainder, which isn't important. Okay, and this would be our slant asymptote. Okay, so let's look at what we're going to need to actually graph. Okay, so these are the 3 things that you really need for graphing. Okay, so the first thing you need is the intercepts, both x and y. Okay, the second thing you need is the asymptotes. Okay, and then the third thing you need is a sign chart. Okay, now we didn't talk about the intercepts or the sign chart because you guys already know how to find those. We talked about sign charts when we did inequalities, and intercepts, you just plug in x equals 0 for the y-intercept or y equals 0 for the x-intercepts. Okay, so let's do some graphing. Okay, so the first thing we're going to do is find the intercepts. Okay, so to find the x-intercepts, we would set y equals 0. Okay, which would leave us with 0 equals 2, which is false. Okay, so that means there are no x-intercepts. Okay. Then we would find our y-intercept by letting x equal 0. Okay, so we found our y-intercept 0, 1/2. Okay. So to find our asymptotes, I'm actually going to factor the denominator here. Okay, and that lets me see my vertical asymptotes because I can see the roots here. Okay, so my two vertical asymptotes are going to be, right, x equals 4 and x equals 1. Okay, one for each root that you see here. All right, and then we're going to look for any horizontal or slant asymptotes. So the degree of the numerator is 0, right? There's no variables at all. The degree of the denominator is 2. Okay, this is larger. So there's a horizontal asymptote at y equals 0. Okay, and then I'm going to make my sign chart. Okay, so you're going to include all the x values that are roots of both the denominator and the numerator, just like we did before. So here we'll have 1 and 4. Okay, and then we're going to list all of our factors. So x minus 4, x minus 1, and 2. Okay, I'm going to assume you guys remember how to fill this out. Okay, and remember when you have a constant, you're just putting the sign of that constant. So because 2 is positive, you just put positive. Okay, and for the quotient here, we're going to get 2 negatives and a positive is positive, negative, positive. All right, so let's look at our actual graph. Okay, so the first thing we're going to do is put in our asymptotes. So we have a vertical one at 1 and a vertical one at 4. Okay, and then we have a horizontal one here along the axis. Okay, then we're going to put in our intercepts. Okay, there's one at 0, 1/2. Okay, and now you have to start by looking at the left-hand side. Okay, so when you look at the left, you're seeing that the graph is positive. Okay, remember the horizontal asymptotes give you the end behavior. So you're going to point your graph positive, meaning above the x-axis, but along the asymptote here. Okay, then all you know now is that you have to get to this point. So I'm going to draw my graph connecting to that point. Okay, and then my graph is still positive all the way up to 1. So because my graph has to go along this line, I only have two choices. I can draw my graph going up along the line, or I can draw it going down along the line. Okay, so because it's a plus, I'm going to go up like that. Okay, so that's one part of my graph. Now I'm going to look here at the negative sign. Okay, so that means this part of my graph has to be down along the line. Okay, so I'm just going to show my graph coming up. Now here I have to decide if my graph is going to go up or down. Well, I look at my sign chart, it has to go down. So I draw my graph going back down like that. Okay, now I'm going to start over here. My graph is positive. I can either start up or down. Because I have a plus, I'm going to start up. Okay, and then the only other thing I know is that my graph has to end up going along this line and it has to be positive. So I'm going to draw it going out like this. Okay, a lot like the first part. So this is the bottom of the graph and then that's the top. All right, let's look at some more examples. Okay, so we're going to find the x and y intercepts. Okay, so there's my x-intercept, -1, 0. And for my y-intercept, I'm going to set x equal to 0. Okay, and I get my y-intercept 0, 1/2. All right, now I'm going to find some asymptotes. My vertical asymptote is going to come from the root of this. So my vertical asymptote is going to be x equals -2. Okay, and then I'm going to look at the degrees to find either the slant or the horizontal asymptote. So the degree of the numerator, right, is 1. The degree of the denominator is also 1. They are equal, okay, which means that I have a horizontal asymptote, okay, and it comes from a ratio of the leading coefficients. So my coefficient in front of x in the numerator is 1, okay. My coefficient in front of x in the denominator is also 1, okay. So that means I have a horizontal asymptote at 1. Okay, let's make my sign chart. Okay, so remember you're including the roots from the numerator and the denominator, so it's going to be -2 and -1, okay, and you're going to include the factors from the numerator and the denominator. Okay, so this is my final sign chart, plus, minus, plus. Okay, now that we have all that, we're going to look at our graph. Okay, so I'm going to put in my asymptotes. I have a vertical asymptote at -1 and a vertical asymptote at -2. Oops, no I don't. I lied. It's just at -2. Start over. Okay, so my only vertical asymptote is at -2. Sorry, I don't know what I was thinking about. My x-intercept is at -1. My y-intercept is at 0, 1/2. Okay, so I'm going to start on the left. Oh, and my horizontal asymptote is at 1 here. Okay, so I'm going to start on the left. Okay, and just to remind you, this is what my sign chart looks like. So when I'm starting on the left, everything should be positive. So I want my graph to be positive and to be along the line. So I'm going to start it here. Okay, and now my line can either go up or down. So because I had a plus, it's going to go up. Okay, and then I'm going to start over after the line. Okay, so after -2 here, I have a minus. So my graph is going to be down. Okay, and then I know it has to hit this point and this point. So I'm going to hit that point and that point. Okay, and then all I know now, after -1, my graph has to be positive. Okay, and it has to go along the line. So I'm going to draw it going along the line here. Okay, looks a lot like the 1/x graph. It's not exactly the same as that, but it does have that same shape. All right, let's do a couple more examples. Okay, So first I'm going to find my intercepts. Okay. So I'm going to set y equal to 0. Okay, so I get the intercept -1, 0. And then to find my y-intercept, I'm going to set x equal to 0. Okay, and I get my y-intercept 0, 1. Okay, then I'm going to look at my vertical asymptote, which remember is only based on the roots of the denominator. So the only root down here is going to be 1. Okay, now the degree of my numerator is 1. The degree of my denominator is 2. And whenever the degree of the denominator is larger, like it is here, you have a horizontal asymptote at y equals 0. Okay. All right. So we're going to make our sign chart. Okay. So our root from the bottom is, our root from the numerator is -1. Our root from the denominator is +1. Okay. And then we're going to list all of our factors. So we have x minus 1 squared. So remember from before, you can either have it squared or you can list x minus 1 twice. Okay, so x minus 1 squared is always positive, and x plus 1 is going to be minus plus plus. So this is going to be minus positive positive for my quotient. Okay, and let's look at our graph. Okay. All right, so we're going to start by putting in our vertical asymptote, which is at 1. Okay, and then we're going to mark our intercepts. So we had our x-intercept at -1, 0, our y-intercept at 1, 0. Okay, and then we're going to look at our sign chart. So our horizontal asymptote was at 0, which is here along the axis. Okay, so we're going to look at our sign chart. It was negative to begin with, so we know that it goes along, but it has to be underneath because of the minus. Okay, now I know that here my graph hits that point, so I'm going to hit that point. Okay, and then at -1, you can see on the sign chart that it changes from negative to positive. Okay, so we're going to do that. We're going to change from negative to positive. Okay, and we're going to get this point in our graph. Okay, now here I either have to go up or down, and because of this section our graph is positive, it's going to go up. Okay, now I'm going to start over after 1. Now our graph is still positive, so I'm going to start from up. Okay, and then I need to draw it going along here like this, I know, above, and I'm just going to connect them in a smooth way. Okay, so that's what that graph looks like. I just wanted to point out that sometimes people are worried about this because you think a graph can't cross an asymptote. A graph can't cross a vertical asymptote. A graph can cross a horizontal asymptote, but you should only draw it like that if you know for sure that it does cross. Okay, like in this example. All right. Let's do 2 more examples, I think. Okay, so here I'm going to go ahead and factor these. Okay, so that makes it easier to find the intercepts and the, x-intercepts and the vertical asymptote. So here I'm going to find the x-intercept. Okay, so I'm going to set y equal to 0. Okay, and like I said, because you're trying to solve an equation, the factored form is better for this. Okay, so I'm going to get two solutions, one from each factor being 0. Okay, so I have two intercepts, 0, 0, and 2, 0. Okay, and then I'm going to find my y-intercept. It doesn't really matter if you use the factored form or the unfactored form. Okay, and I'm going to get that my y-intercept is 0, 0, the origin, which you could have known by looking at this. Okay, so now that I have those, I'm going to look at my vertical asymptote. Okay, and this is coming from the roots of this denominator. Okay, so this is another reason to factor. So I would have mine at -4 and -3. Okay, and then I'm going to look at the degrees. So the degree of the numerator, this is easier to see in the unfactored form, here is 2. And the degree of the denominator, okay, like I said, is easier to see in the unfactored form, here is also 2. So they are equal. Okay, so we know that we have a horizontal asymptote, and we're going to get it by making a ratio. Okay, so we're going to take the leading coefficient from the numerator, which is 2, okay, over the leading coefficient from the denominator, which is 1. Okay, so that's what I got here, which gives me y equals 2. All right, let's make our sign chart. For here, it is definitely easier to use the factored form. So my roots were -4, -3, 0, and 2. I'm going to extend this a little bit. Okay, and my factors were 2x, x minus 2, x plus 4, and x plus 3. Okay. Okay, so now for my quotient, I have 4 negatives, which is a positive, 3 is a negative, 2 is positive, 1 is negative. All right, so I have plus, minus, plus, minus, plus. Okay, so let's look at my graph. Okay, so the first thing I'm going to do is mark my asymptotes. So my vertical asymptotes were at -3 and -4. Okay, they're close together, that's okay. And my horizontal asymptote was at y equals 2. Okay. My intercepts were the origin and 2, 0. Okay. So I'm going to start on the far left, which is this part, this little part up here. Okay. Now over here, if you look at the sign chart, right, it is positive. So I'm going to show the graph here. Okay. And then because it's positive, I have to show the graph going up. All right. Now between -4 and -3, the graph is negative. Okay, so it has to go down here. Okay, and then it has to go back down because the graph is negative the whole time. Okay, now between -3 and 0 up here, the graph is positive. So I'm going to show the graph coming down from up here. Okay, and I know that my graph has to hit this point at 0. Okay, so my graph is just going to come down here and hit this point at 0. Okay, and now at 0, you can see it crosses from positive to negative, so it's going to go down negative. Okay. Then here at 2, you can see it crosses from negative to positive. So I'm going to make my graph cross from negative to positive like that. Okay. And then after that, the graph is positive the whole time, which is good. And I'm just going to draw it going along my horizontal asymptote like that. Okay, so this graph kind of has 3 sections. This part up here, this part down here, and then this part over here. All right. One more example. Okay, so again, I'm gonna factor this just so that I can use that for certain parts. Okay, so I'm gonna find the x-intercept first. Okay, get 2 solutions from that, which gives me 2 intercepts. Okay, for my y-intercept, I'm going to set x equals 0. Okay, and that will give me the point 0, negative 6. Okay, then I'm going to look at my vertical asymptotes. Okay, that comes from the denominator here, so that's going to give us x equals negative 1. Okay, and then we're going to look at the degrees. So the degree of the numerator, you can see it better in the unfactored form, is 2. The degree of the denominator is 1. Okay, so remember, this is a special case where the degree of the denominator plus 1 is the degree of the numerator, right? This is 1 more than this one, okay? So that means there's a slant asymptote. Okay, and we're going to find this by dividing. So you're just dividing the numerator by the denominator. Okay, so x into x squared is x. Subtract. This gives me minus 2. Okay, and that's minus 4, which is not super important. Okay, so this gives me my slant asymptote. Remember, it's only coming from the quotient. The remainder isn't important. And I get that. All right, let's look at our sign chart. Okay, the roots are negative 2, negative 1, and 3. Okay, and my factors are x plus 1, x minus 3, x plus 2. Okay. All right, so let's look at our graph. Okay, so I'm going to put in my asymptotes. So my vertical asymptote was at x equals negative 1. Okay, and my slant asymptote is the line y equals x minus 2. So you just graph the line y equals x minus 2. So here's my y-intercept for that line, and then the slope is 1. Okay, so that asymptote is going to look like this. Okay. All right. And then I'm going to put in my intercepts. 3, 0, -2, 0, and 0, -6. Okay. Now I'm going to start on the left side, and on the left side the graph is negative. Okay, so I'm going to draw the graph going along this slanted line like this. Okay, and then it has to hit this point, so I'm going to graph it going up like this. Okay, and now at -2 it changes from negative to positive, right? So I'm going to draw it going across from negative to positive, and then because it's positive it's going to go up along that line. Okay. Now after that, after -1, right, which is this line, it's going to be negative. So I'm going to draw it going down like this. Okay. I know my graph hits this. Okay. I know the graph hits this point, so I'm going to connect them. Okay. And after 3, the graph should be positive. So I'm going to draw it going up and along that line. Okay. So this is kind of a funny looking graph. Okay, it's mostly because it's really stretched out. It should be smoothly connecting, but it's hard to do that when you're graphing by hand. Okay, so at this point, I don't think any more examples would be any more explanatory, but it's really important for this type of stuff that you are practicing. So I encourage you to practice. There is a worksheet for this stuff, and there's also some questions in the homework. So I'll see you guys soon.